Boolean algebra was given by English mathematician George, born in 1815. So what is Boolean algebra? How to use Boolean algebra? What are the drawbacks of Boolean algebra? And finally, what are the alternatives to this Boolean algebra we have to study in this presentation? It is a very important topic and definitely there will be a problem from this topic in your exam. So please pay attention. Now we'll start. It is this set of rules used to simplify the given logic expression without changing its functionality. So it is nothing but a set of rules. We will see what are these rules and how to use them. And these rules are used to simplify or minimize the given logic expression. So initially there will be a logic expression given to you. Let's say f is my function and it is equal to a complement b or bc or abc. So this is the logic expression given to me and now I have to minimize it by using this set of rules. And let's say the minimized result is a complement b or bc. Now there is one very important thing that you can see. The minimized expression, this one, and the initial expression should have the same functionality. Without changing its functionality, we have to minimize it. So if I say this is my expression number 1 and this is my expression number 2, then the expression number 1 and expression number 2 must have the same functionality. And this is one of the drawback of the Boolean algebra, because you have to check it by using the truth tables whether they have the same functionality or not, whether you have used these rules correctly or not. Because if two persons are solving this problem, then one may have the different approach, another may have the different approach. One may stop just after this, he will not go here and he will think that this is the minimized one because he is out of ideas, whereas someone can go up to this result. So the final result in case of Boolean algebra is not always same. This is one of the drawback. And also you can see it is used when the number of variables are less, more precisely 1, 2 or 3. If the number of variable is 1, 2 or 3, then it is good to use Boolean algebra. If it is more like 4, 5 or 6, it will be very tedious to use Boolean algebra, and in that case we introduce a new method for the minimization that I call as the map method. The map method, METHOD, or we call it as the Karnaugh map or K-map method for the minimization of the logic expression that we will see later. So you now have some idea about the Boolean algebra, and we have to minimize the function by using this set of rules. And why I am calling this minimized function? Because we have minimized the number of gates. If you see initially here I have used one AND gate, 2 input AND gate, and there is NOT gate also. I have taken the complement of A and it is done by the NOT gate. Then I have another AND gate and the 3 input AND gate is there, and finally one OR gate to OR them. So in total I have used 5 gates, 5 logic gates, whereas in this case I have used the NOT gate, I have used AND gate, another AND gate and one OR gate. In that way I have used 4 gates. So from 5 gates I have moved to 4 gates and the functionality is same. So why to use one extra gate when we can have the same operation by using the 4 gates? This is the beauty of the Boolean algebra. You can have reduced number of gates by just simple set of rules. These rules are really very simple. Nowadays reducing the number of gates is not a big deal because one gate is really very cheap and there are thousands of gates in the digital systems, and just reducing one gate is not making very much difference. But definitely one gate must have some cost, and our operation will also be fast because every gate will take its time to produce the output. The power used, the power dissipation will also decrease because gates need some power for the operation. So overall it is a good condition for us to reduce the number of gates, and we will use Boolean algebra for this purpose. So this was the brief introduction of the Boolean algebra. Now we will move to the set of rules, but before that I have to explain you what is the logic expression. For this I have taken one example, and in this example I am deciding whether to take my umbrella outside or not. So take umbrella is the output and I will denote it by Y, and this depends upon 3 factors. The first one is whether it is raining outside or not, and I will call it A. The second one is rain forecast, B, and the third one is take the car. So these are the 3 factors on which my Y, the output, depends. I have to take umbrella and I will decide depending upon these 3 factors, and in that way we will have a function or expression that we have to find. So Y is equal to, you can see the output here is A or B because we have used OR gate, and if it is raining outside, you have to take umbrella, or if the rain forecast is there, if they have forecast that it will rain, then you have to take umbrella out. So I will write A or B, and then I have used AND gate. I have used AND gate. This dot represents the AND gate, this plus represents that we have used the OR operator. Then take car and the NOT gate is used, so here the output is C complement. So finally we have output as A or B and C complement. And if you are taking your car, there is no need of umbrella. So a typical logic expression will look something like this. I am not explaining it much because you don't have the background. And I can also write this expression y equals to B A C complement or B complement A C complement or BC complement. So these two functions are same, they have the same output, and I have reduced this function to this. I have reduced this to this by using the set of rules. And this is our example. I will first explain the set of rules, then we will see how to solve this. So let's start with our rules. The first rule is the complement rule. The complement rule. If you take the complement of A, then it is represented as, if you take the complement of A complement, it is represented as A bar or A prime, or I can also write it not of A. Now you already know, if I take the complement of 0, then it is 1, and if I take the complement of 1, then it is 0. And what happens if I take the complement 2 times? So if I take the complement of A and then again take its complement, then it is equal to A. So if you are having a variable and you are going to take its complement and then again its complement, you are going to have the same variable. Here I can say the complement of 0 is equal to 1, and if I again take the complement of 1, then it is 0. So it is equivalent of taking the 2 times complement of 0, and it's going to be 0. So this is important rule and you will use it so many times. Now let's move to the rule number 2, and in this we will see the AND operator. You all know what is AND operator. If there are two variables A, B and output is Y, as there are two variables, in total I have 4 possible combinations. 2 to the power 2 gives me 4, and the combinations are 0, 0, 0, 1, 1, 0, 1, 1. And in AND operator, the output will be high or 1 only when both the inputs are high. These are my input and this one is my output. Now this output will be high only when both A and B are high. So in first case, you can see both of them are low, so the output will be low. A is low and B is high. In that case also output is going to be low. A is high, B is low, output is low. And in the last case, you can see A is high as well as B is high, so the output will be high. So this is AND operator, and we implement this concept by using the AND gate. It is represented like this, and we have 2 inputs here. In this we can have 3 input, 4 input, and further more inputs are allowed depending upon the voltage level. And now I am considering the 2 input AND gate. The output is Y, and then it is represented as A and B. This dot represents AND. Now let's see what rules are there. The first one is A and A. What will be the value if I take the AND operation of the same variable? If I replace B with A, then I have A and A. And you can see, if I have same variable, definitely we have 2 possible combinations. Either A is equal to 0 or A is equal to 1. Let's consider the first case. When A is 0, we have 0 and 0. I'm just putting A equal to 0 in this. And 0 and 0. 0 and 0 is definitely equal to 0. So this is equal to 0. And if A is equal to 1, then we have 1 and 1. 1 and 1 gives us 1. So it is equal to 1. So it is very simple to see that the output, this is my output, is equal to A itself. Because A was 0, we have output as 0. A as 1, we have output as 1. This is my output. So I can say that A and A gives me a very important rule. We will use it a lot. And if I have A and 0, then definitely it is going to be 0, because in AND operation both the variables must be high to give the output high. But here always one of the variable is low, so output will be low whatever be the value of A. If A is 1, we have 1 and 0, and this is a 0. From here you can see, if we have A as 0, then 0 and 0 is also 0. So every time the output is going to be 0. So I have written a 0 here. Now we have A and 1, and this is going to be A. From here you can see, when the other input, let me change the color for this, when the other input is 1, okay, then the output is going to be the first input. If it is 0, the output is 0. If it is 1, the output is 1. So we can write A as the output. Very simple. And the last one that we have to see in this is A and A complement. This is one of the most important rules in Boolean algebra, and it is used a lot. So let's find out what will be the output in this case. Let's take the first case when A is equal to 0. Then in that case, A complement is equal to 1. This implies A complement is equal to 1 because I have already explained this thing in the complement law. And if I take its AND operation, then A and A complement is 0 and 1, then it is going to be 0. And let's consider the other case when our A is equal to 1. When A is equal to 1, this implies that A complement is equal to 0. And if I take the AND operation of these two variables, I have 1 and 0. And from here you can see 1 and 0 is equal to 0. So in both the cases, we have 0 as output. So simply I can write the output as a 0. So in this way we have 4 rules in AND operation, and they are very important. They are very important. I don't know how many times I am going to use this in this course, and I request you to learn this thing right now. You have to only know about the AND operator. Once you know what is the AND operator, you can find it in the exam. If you stuck at any point, you don't know what will be the output, just follow these steps that I have already shown you, and you can have your output. So this is a very important thing. In the same way, we can find out the 4 rules for the OR operation, and we will follow the same steps. I'm not going to do all the steps for you, but you can do it. The first one is A or A, and this one is equal to A. Let me do it. It will not take much time. In OR operation, the output is high if any of the input is high, and there are 2 variables, so 4 possible combinations. I will do it quickly. So these are the 4 combinations, and if any of the input from A or B is high, the output is going to be high. In the first case, both of the inputs are low, so output is low. Here B is high, so output is high. In this case, A is high, so output is high. And in the last case, both A and B are high, so output is going to be high. So this is the table for the OR operation, and we implement it by the OR gate. The OR gate looks like this. Okay, and we have 2 inputs. The inputs are A, B. The output is Y, and it is represented as A or B. Now let's see how we got this A or A equal to A. If I have the same input, then this Y is going to be A or A. And if A is equal to 0, the Y is equal to 0 or 0, and 0 or 0 gives me 0. So this is equal to 0. And if A is equal to 1, the Y is going to be 1 or 1, and 1 or 1 gives me 1. So you can clearly see whatever be the value of the variable, we are having the output same. Here A was 1, so output is also 1. Here A was 0, so output is 0. So the output is simply A in both the cases. So I have written A for this. And the second rule is A or 0. A or 0, let's see from this table. When the other input is 0, the output is simply equal to the first input. Here the first input is A, it is 0, so the output is 0. Here the first input is 1, so the output is 1. So I can write it as A. And the third one is A or 1, and this is equal to 1. This is the most important rule. I am going to highlight this. This one especially very important. And whenever you have anything odd with 1, the output is going to be 1. If it is A complement BC, BC A complement B, if this 1 is there, this whole part has no meaning. The output is going to be 1. The output is going to be 1 because of this small 1 here. So this is a very important thing. Sometimes it saves a lot of time. You don't have to minimize this part because it is odd with this 1. If I consider it X, then we have X or 1. And whenever anything is odd with 1, the output is going to be 1. So this one is very important, and it will help you a lot in your exam. And the last one is A or A complement, and this one is simply a 1. Now let me prove these 2 things, and then we will end this presentation here. I will explain rest of the rules in the next part because we are already pushing the time. So I will explain this one, how we got A or 1 equal to 1. When A is equal to 0, let's put A equal to 0 here. We have 0 or 1. 0 or 1, from here you can see it is equal to 1. So this one is 1. And when A is equal to 1, I will put 1 here. So this one is 1 or 1. And from the last combination, you can see 1 or 1 is equal to 1. So in both the cases, we have output as 1. And for the last one, let's take A equal to 0. So we have A or A complement. A is 0. And A complement is definitely 1, complement of 0. And 0 or 1, from here you can see 0 or 1 is equal to 1. And if A is equal to 1, we have 1 or 0. This is A and this is A complement, and we are taking the OR operation. In that way also, from here you can see the output is 1. So You can prove it when you need, but it is good to remember it. And I'm not telling you to mug this up, but solve a lot of problems. When you solve so many problems, this thing will be on your tip. You will use it, you will learn it in the way. I'm going to explain you so many problems on the Boolean algebra so that it will be easier for you to remember these things. I will end this presentation here. From the next presentation, we will continue with our associative, commutative, distributive laws. So see you in the next one. We will also study the De Morgan's law, a very important one. So see you in the next presentation.